In here, we have a truly interesting question in quantum chemistry where you're asked how many electrons are in the 3D orbital with an element with an atomic number of 26. We have the following options, and I'm going to show you the mathematical way of approaching this using interesting formulas that needs to be understood in order for you to get this across really done really well. And so here is the first step. The first step here is to recognize what we know is our value for n, which is known as what? The principal quantum number. And why are we picking n? Because in this question here we have our 3D, and the 3 here, it represents our n value, and this n value is what? Describing the energy level. And so the n here, which is what? The principal quantum number here, is going to allow us to dive into the how many electrons are in each level. And so we're going to start first with the first one, which is our 1. And when we go into the maximum number of electrons that can be contained in that energy level number 1, there is a big formula to remember, which is the 2n to the power of 2. And so when we apply the math here to this one here, this means that we have a 2 times 1 to the power of 2, and this gives us the value to be equal to 2 electrons. And so since we have 2 electrons, the big one here is we need to now look at the number of electrons that is given in the question, and it says that we have 26. So we're going to start with our first value, which is 26 electrons, and what we're going to do is going to do minus 2 electrons. That gives us what? 24 electrons to go. And now the next step is we're going to move into the next energy level number 2, and we're going to apply that formula. And what happens is 2 to the power of 2 gives you 4 times 2 gives you 8. So we have 8 electrons that can be contained in that energy level. Now we're going to do 24 electrons left minus 8, and this gives us how much? 16 electrons. And now we have 16 electrons. Let's move on to the next energy level, which is number 3. And in this case, for number 3, let's see the maximum number of electrons that can be contained in that energy level. And so in here we have 3 to the power of 2, which gives you 9. 9 times 2 gives you what? 18 electrons. And so what we realize is that in here, because we have 16 electrons available, but we have this particular energy level that can contain 18 electrons, that means we're going to be playing around with the number 16 in the next particular quantum number. And this is where it comes into play, where we'll be looking at quantum number what? 2. And quantum number 2 here is labeled to be what? L. And our L represents what? The angular momentum. And for angular momentum, we're going to be looking at what? The specific number of electrons that can be filled at the sublevels, or we can call it the orbitals. And so first is that for R3, when we start with our n equals 3, because that is our star here, and in this question, when we look at it, we are now focusing on the orbital section, which is the D. We're going to be looking at how to get to the D part. We're going to now begin with this particular L to be equal to what? Equal to 0 as the first orbital in the n equals 3 energy level. And so this here is in the same thing as saying we have our spherical orbital, which is a 3s orbital. And this here, when we look at the maximum number of electrons that can be contained in that particular orbital, there is a new formula that you need to remember, and this formula is known as what? The 4 multiplied by the L plus 2 formula. And when we apply this to this question here, we have our value to be equal to what? In this case, 4 times 0, which gives us 0 plus 2, that gives us what? 2 electrons. So now we're going from, we're starting at 16 electrons, and we're going to minus 2 electrons, and this gives us how many electrons to go? We have what? 14 electrons to go. And now the next part is moving from 0 to what? 1. in terms of the angular momentum. And the following one here, this is the same thing as the orbital 3p. And the p is when we look at how many electrons that are going to be contained at the p orbitals. For the 3, we have our 4 times what? We have our 4 times 1, and our 1 is going to be giving us our 4, and our 4 plus 2, that gives you what? That gives you 6 electrons. And so this here is the number of electrons that can be accommodated at the p orbitals. And so our 14 electrons, we're going to minus 6, and that will give us how many electrons left? We're going to have 8 electrons to go. And so these 8 electrons, let's see whether we're going to have excess of them or we're going to have limited amount of them. So let's see by going into the next orbital within the 3 energy level. And in this case here, the next is number 2. And number 2 here implies that we are looking at the orbital d orbital. And so our 3d orbital here, when we apply our maximum number of electrons to see how much it can contain, we have 4 times 2, that gives you 8. Then you add R2 to that answer, and that gives us 10 electrons. But in here, there's an interesting plot twist, and this plot twist might make you think that, hey, the answer is actually 8 electrons, as you see here as the options in this question. But not really, not at all, because you have to consider another condition, which is a rule known as the n plus l rule. And this n plus l rule allows you to consider not only the principal quantum number energy levels, but also the angular momentum's energy levels. And these two has to be considered in order for we to place our electrons in a more stable state. And what does that mean? We're going to look at 3 energy levels, and considering the orbitals, we're going to look at the 3p orbital. And the 3p orbital, when we apply the n plus l rule, this means that our n is equal to 3 plus our p is equals to 1, and this here is when you add them together, that gives the number 4. Now let's look at the 3d and apply our n plus l rule. In this case here, our n is equal to 3, and we're going to add our l. In this case, our d is equal to 2. That means when we have 3 plus 2, that gives us 5. Now at the n equals 3 level, that is it for the orbitals, the s, the p, and the d. Now let's look at the next level, which is the 4s, and let's see what the n plus l rule is. And this shows something quite fascinating here, which is this: that when we have our n to be equal to 4 plus what our s is represented as 0 for l, and we put that in, this here is equal to 4. And what we see is that our S3p and our 4s has the same n plus l rule, but because our energy level n value 3 is lower than that of 4, it means that we're going to fill the 3p first before we fill our 4s. And so our 4s order is going to be next after our 3p, and then our 3d, because our n plus l rule is 5, which is greater than our 4s's n plus l rule. That means our 3d will be filled later. So that is the actual order. The order is we're going to fill our 3p first, followed by our 4s, and then we fill our 3d. So what does that mean in this particular question here? That means that now we're done with the 3p, we're going to consider the 4s electron filling here, which means that we know that our 4s has the maximum number of electrons to be accommodated, because it's the s orbital, to be equal to 2 electrons. That means we're going to apply our 8 electrons that we have left, and that 2 electrons, when we put those into the 4s, we are left with 6 electrons, and that 6 electrons that is left will then be placed in the 3D orbital. And so in here our final answer is what? 6 electrons is going to be in the 3D orbital, not 8 electrons. And so our final answer is not 8 here, but it is what? 6. So quite fascinating to consider all the variables in terms of using math, not only using the principal quantum numbers, maximum number of electrons, but also the angular momentum, maximum number of electrons, and considering the n plus l rule to determine where the electrons will go in terms of the differences in the energy levels between the 3D and the 4s orbitals. 4s always gets filled up first before we move on to the 3D. Overall, I hope you found this really informative in terms of this particular video. Other additions might be the following: how are we going to place these 6 electrons in the 3D orbital? Now, the 3D orbital has 5 degenerate orbitals, and we'll talk about degenerate orbitals in details. If you want to look at them in terms of the magnetic orbitals, we have our 5, which are the numbers -2, we have -1, we have 0, we have +1, we have a +2, and they have different orientation in space when we talk about those in details. But in here, in terms of filling, we're going to first start with what? Our electrons placed as up spins, which in this case we have 1, 2, 3, 4, 5, and then we put our pairing up with the down spin, and that is our number 6 electron right there. So hope you found this really informative. See you all on the next one. Stay smart as always and keep on practicing.